everybody, welcome to TechStruct Hub. We simplify the data structures and algorithms. In today's video, we will cover an essential topic. What are the general BIGO time complexities and how do you calculate the runtime of an algorithm using BIGO notation? Let us dive into the details and break it down step by step. By the end, you will know exactly how to analyze and understand algorithm performance. So let's get started. In previous video, we introduced our BIGO notation O of n. Today, let's dive deeper into calculating BIGO notation and have some fun with exercises. What are the generally used BIGO time complexities? They are O of 1, O of log n, O of n log n, O of n power 2, O of 2 power n, and O of n factorial. In today's video, we will be learning how to calculate runtime of a function. Let us start with simple function. In this function, I am printing the first element of an array. Regardless of the size of the input, whether it is 1 element, 10 elements or 100 elements in the input, we are always printing the first element of an array. Let us run this and we can see that it is only printing first element of an array. This is known as constant time O of 1 because the number of operations doesn't change as the input increases. This will be O of 1. When we look in the graph, O of 1 comes under dark green area, which is an excellent runtime. In our previous video, we have seen example of O of n time complexity and this example have O of 1 time complexity. Let us do some fun exercises calculated runtime of algorithms. With our exercise in this video, I would like to show you the details of runtime calculation so that you have nice foundation so that moving forward we can simplify things a lot better. Let us calculate time complexity of this function. Let us go step by step. When this function is run, the first thing it is doing is it is assigning a value to the variable a. Some people say you should not consider BIGO for assignment and some people say you should. For this exercise, let us calculate the runtime step by step. When this function runs, the first two lines a is equals to 1 and a is equals to a plus 5 are constant time operations, which is O of 1. Then we enter the for loop which runs n times, which is the length of the input. For each iteration, we are printing the element in the input and incrementing the value of a variable a by 1. Both these actions are constant time operations which are running n times, making the runtime of the for loop O of n. Finally, we have a return statement which is also O of 1. So we have all these BIGO notations. Let us total all this up. We see that we have 3 O of 1s and 1 O of n time complexities. So summing up everything, the runtime can be written as O of 3 plus n. However, in BIGO notation, we simplify by ignoring constants. So this simplifies to O of n. In this example, we see that we have to do little calculation adding runtime of every step like 3 plus n. In interviews, we are never going to do this. Now, you might ask me, then why did we do such calculation just now? We went through that exercise to give you guys an idea of how PICO gets calculated. In interviews, you are not expected to go step by step like we just did. Instead, you analyze the code and provide the overall time complexity. For example, this time complexity of this function will be O of n. When we talk about time complexities in interviews, most of the time we are going to give one of these answers. Generally, when we calculate runtime of an algorithm, there are 4 rules we can follow. Rule number 1, worst case. Rule number 2, remove constants. Rule number 3, different terms for input. Rule number 4, drop non-dominants. By following these 4 rules, instead of doing the small little calculations as we did in our exercise, we can simplify the calculation of BIGO instead of doing step-by-step calculations. Now, let us talk about rule number 1, worst case. For this, let us define a simple example. Here, I am declaring an array of strings. I am declaring array of fruits and I want to find if strawberry is part of this array. For this, I am looping through the fruits array and I am printing running so that we can see how many times the loop has run, and also I have an if statement to check if that element is strawberry. If that element is strawberry, I am printing found strawberry here. Now let us run this. How many times did this loop run? Right now, even though we found strawberry at the fourth position, our loop kept running. So the loop ran for 9 times. Let us put a break statement here and see what happens. Let us run this. This loop will run only 4 times because it found the strawberry. As we have break statement, the loop is breaking from since it found strawberry. This loop is little bit efficient when compared to previous loop, right? When it comes to big O, although we write good code, in big scheme of things, big O cares only about the worst case. What is the worst case in our example right here? The worst case is strawberry instead of being the fourth item, it could be at the end of the array, which in turn leads to number of times we loop being equal to length of the array. Best case is having strawberry at the beginning of the array. Then we had to do only one operation. Worst case is having strawberry at the end of the array or not having the fruit in the list at all. Hence, the time complexity of this function falls under O of n. This is our first rule. The first rule is we always care about worst case scenarios only. We can't assume things going well. Even though the above example runtime could be O of 1 if we have strawberry at the very beginning of the array in the grand scheme of things, because we can't be certain of what input it is going to be, we are going to assume that the time complexity is O of n. Now, let's look at rule number 2, remove constants. For this, let us consider our previous example. In this example, we have calculated the runtime as 3 O of 1s plus O of n, which is O of 3 plus n. Rule number 2 states we have to drop constants. We simply mean that we don't define the runtime as O of 3 plus n. We only care about the runtime we see as the input increases. When calculating time complexity of an algorithm in grand scheme of things, we only care about the number of elements in the input increasing. When n gets bigger and bigger, we don't care about adding an extra 3, right? With the n value is million, plus 3 doesn't make any real impact. Hence, we drop the constants and the time complexity of this function will be O of n. Now, let us look at rule number 3, different terms for input. For this, I have defined a simple example, which accepts two inputs, input 1 and input 2. And for each input, I am multiplying the element of that input with 2 and printing that input. Let us calculate the time complexity of this function. Here, input 1 could be of length 10,000 and input 2 could be of length 2. First for loop depends on the length of input 1, whereas second for loop depends on the length of input 2. In big O notation, n is just an arbitrary letter used in the notation. We can use any letter for that matter. The runtime of this function will be depending on these two for loops. Here, for the first for loop, let us consider a as the arbitrary letter. We are using the time complexity of this for loop, and as it has constant time operations inside the loop, the runtime of this loop will be O of A. And for this for loop, it also has a constant operation, so the runtime of this loop is also O of B. When we calculate the total runtime of this function, it will come as O of A plus B. If you want to use n arbitrary letter, then it would be written as O of n plus m. What happens if we use same arbitrary letter for both inputs? Like what happens if I use n for both these inputs? Then the runtime will not be defined well, as inputs could be of different sizes and number of operations performed on input could also vary and it could lead to wrong result. Let us consider a scenario. Input 1 is of size 1 million and the runtime of performed on this input 1 could be O of n, whereas the size of input 2 could be 2 and the number of operations performed on input 2 could be O of n power 2. According to rule number 4, which we'll be looking into shortly, if we use same arbitrary letter for both inputs, the final runtime will be O of n plus n power 2 will be written as O of n power 2, which is misleading, right? Because it, it is different for each input size. The actual runtime should be O of n plus m power 2. Hence, we always use different terms for different inputs. Let us look at rule number 4, drop non-dominance. What does it mean? Let us look at another example. I'm writing a function to print sum of all pairs. Let us calculate our time complexity of this function. The first loop runs n times, which becomes O of n time complexity for this for loop. In the second loop, for each number, we are looping through the input again and we are calculating the sum of pairs. Let us run this one first. Okay. In my input, we have 1, 2, 3, 4, 5 as my input. When my auto loop reads 1, the inner loop loops through the input again and print the sum of 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5. Hence, the runtime of second loop becomes n into n, which can be written as n power 2. Rule number 4 states that we drop the non-dominance. If we add up these two runtimes, the runtime could be written as n plus n power 2. Here the non-dominant is n. Hence, the final runtime will become O of n power 2. As input size increases, the size of n to the power of 2 is important than n. So we are dropping n here. Now we have covered all the 4 rules. In this video, we have explored how to calculate and simplify big O notation using 4 key rules. In our next video, we will start diving into data structures starting with arrays. That wraps up this video. If you're finding this content helpful, don't forget to give it a thumbs up and hit that subscribe button and click on the bell icon to get the notification as we upload the video. It really helps the channel and you will stay updated with all the upcoming videos. If you have any questions, please post them in the comment section or you can send them to email directly. Thanks for watching and see you in the next video.